Sample problem 7.01. In 1896, in Waco, Texas, William Crush parked two locomotives at opposite ends of 6.4-kilometer long track, fired them up, tied their throttles open, and then allowed them to crash head-on at full speed in front of 30,000 spectators. Hundreds of people were hurt by flying debris, and several were killed. Assuming each locomotive weighed 1.2 multiplied 10 power 6 Newton and its acceleration was a constant 0.26 meter per second square. What was the total kinetic energy of the two locomotives just before the collision? So in this question, they mentioned some incident happened in 1896, but let's see this question in physics point of view. So here what they did, they took two locomotives. Let's take two trains, and these two trains are parked opposite to each other, and the distance between these two trains are 6.4 kilometer, the long track. Okay, and these two trains are started and they make them to collide with each other. So they asked what is their kinetic energy of the two locomotives. Locomotive means it's a vehicle, right? Now what we have to do, first of all, let's use the formula for finding the kinetic energy. What's the formula for kinetic energy? The formula for kinetic energy, which is half mv square. But here they ask you to find what is the total kinetic energy of two locomotives. That means we have to multiply this formula by 2. So that means the kinetic energy of the first locomotive and the kinetic energy of the second locomotive. That's the reason we have to multiply by 2, because they ask these questions in this problem. We have to find the kinetic energy of two locomotives. So we have to use this formula. But here, if you want to find the kinetic energy, what we need the mass as well as we need the speed. So first of all, we have to find the mass and the speed. But anyhow, what are the remaining things they mentioned in this question? So that means they mentioned, so before the collision happens, that means it will come and head on collided at this point. That means the half of the distance, that means the delta x is nothing but the half of the distance, which is a 3.2 kilometer, which is equal to 3.2 multiply 10 power 3 meters, because here I converted this kilometer to meter. So why we took 3.2? Because the distance between the two locomotives are 6.4 kilometers. So that means when it come and collided with each other at this point, so the distance each travel is 3.2 kilometer. Now what we need the information about the mass as well as the speed. So first of all, we take the mass. How to find the mass? We have the weight of each locomotive, because the weight of each locomotive here they mention as 1.2 multiply 10 power 6. So that means from weight we can easily find the mass. What's the formula? Weight, which is equal to mass multiplied by gravity. Therefore mass, which is equal to weight divided by gravity. So when you substitute the value here, we can easily find the mass. And for finding the speed, what we have to do, we have to use the equation of motion with constant acceleration, which we studied in chapter number 2. Clear? So initially these two locomotives are at rest, and then it will start to move. So that means the initial speed of the locomotive, that means the V0 value we have to consider as 0. Clear? Okay, let's write the given first. Here we already have the value of delta x, because the delta x is nothing but, so at this point it will come and collided at each other. So that means here in this point the distance traveled by each is 3.2 kilometers. That means 3.2 multiply 10 power 3 meter, and then the weight of each locomotive is given as 1.2 multiply 10 power 6 Newton, and also the acceleration value here they mentioned 0.26 meter per second square. Now for finding the kinetic energy of the two locomotives, we have to use this formula, but for finding this kinetic energy we need the mass and the velocity. That means we have to find the value of the mass, that means the mass value as well as the speed, that means the final speed value we have to find, so which is Vf, because the V initial, which is equal to 0, because initially these two locomotives are at rest. So that means the initial speed we have considered as 0. So first of all, what we have to do, we have to find the mass. How to find the mass? by using the weight formula. So weight, which is equal to mass multiplied by gravity, therefore mass, which is equal to weight divided by gravity. So weight here is 1.2 multiplied 10 power 6 divided by 9.8. We got the answer here as 1.22 1.22 multiply 10 power 5 kilogram. So we got the answer for the mass. So let's write the answer one more time. 1.22 multiply 10 power 5 kilogram. So this is the value for the mass. Now we need the final speed. So what we have to do, we have to use the equations of motions with constant acceleration. So let's take the third equation. If you took the third equation, what is our third equation? V final square, which is equal to V initial square plus 2 into acceleration multiplied by the displacement. So here the initial speed is 0. So therefore V final square, which is equal to 0 plus 2 into acceleration here is a 0.26, which is given in the question, multiplied by the distance. The distance is the half of the distance, which is 3.2 multiplied 10 power 3. So we have to use this value, 3.2 multiplied 10 power 3. So here we got the answer as 40.79. So Vf square we got as 1664, and when we take the square root on both sides, the final speed we got as 40.79 meter per second, which is the answer for the final speed. Now, once we find the answer for mass and the velocity, it is easy to find the answer for the kinetic energy of the two locomotives, because as we already written the formula earlier, the kinetic energy of the two locomotive is 2 multiplied by half m v final square. So now I'm going to substitute the value. So here 2 get cancelled with this 2. So only remaining we have the mass multiplied by velocity square, the speed square. So the mass here we got as 1.22 multiply 10 power 5 multiply with this speed, which is 40.79 whole square, and here we got the answer for the kinetic energy of the two locomotive as 2.03 multiply 10 power 8 joules. So this is the answer for this question. That's it. Thank you.